So in chapter 1.1, we're going to review one-variable linear equations. You should have seen most of this information in the previous algebra class, 1310. I would like you to review the pages 99 through 108 in your book, and in this particular section we're going to learn how to solve linear equations in one variables. We're going to identify conditional equations, identities, and contradictions. We're going to look at solving rational equations, and we're going to solve literal equations for a specified variable. So our first objective is to solve one variable linear equation. This problem is number 25 in your book on page 109, and we're going to solve for x. As you can see, we have 2 times 5x minus 6 in parentheses is equal to 4 bracket x minus 3 parentheses x minus 10 parentheses closed bracket closed. So in this particular case, the first step is to use the distributive property. And when we use the distributive property, we are going to just move or multiply the 2 through on the left side of the equation. So we get 10x minus 12, and then we have an equal sign, and we're going to multiply the 3 through the parentheses. So we have 4 bracket x minus 3x plus 30. The next step, of course, is to clear the bracket on the right-hand side. But before we do that, we're going to have to combine like terms inside. So we combine the 3x, the negative 3x, with the x, and we get a negative 2x. And so now we are going to distribute the 4 through. And when we do that, we leave the 10x minus 12 alone, and we get equals minus 8x plus 120. Now what we're going to do is we're going to bring the negative 8x over to the other side of the equation. We get 18x minus 12 is equal to 120, and we add 12 to both sides, and we get 18x is equal to 132. We divide the 18 by both sides of the equation, and we get 132 over 18, which reduces down to 22 over 3, or 7.33 repeated. Notice in this case we use the distributive property a lot. In this case we used combining like terms, and we used the principle of equality, which is whatever we do to one side of the equation we must do to the other side of the equation. Also in this chapter we're going to know the difference between identifying conditional equations, identities, and contradictions. If an equation turns out to equal, the equals don't match up on either side of the equation, we have what's called a contradiction. If we have the value x equals to a particular number, then we have what's called an identity. And then finally, on conditional equations, if we have the same equations where the variables are the same on either side of the equation, we have conditional because x can be any number. So in this particular case, we have, this is number 46 on page 111, we have a negative 5 plus 3x is equal to 3 times parentheses x minus 1 minus 2. Well, the first step is, of course, is to distribute the 3. So in this case we would distribute the 3 in the parentheses, And of course we end up with, we're going to leave the negative 5 plus 3x alone, and we get 3x minus 3 minus 2. We can combine like terms, and we get 3x minus 5 on this side of the equation. But you'll notice it's the same on the left-hand side of the equation, minus 5 plus 3. Well, in this case, we end up, if we cancel everything out on either side of the equation, we get 0 equals 0. Well, that's conditional because x can be any number. It doesn't matter what x is. So that's what a conditional equation is. So now we're going to try to solve a one-variable rational equation. We're going to start off with the denominators not having any variables in the bottom. And the idea here is if we have an equation with rationals, we want to find the LCD first, right? So these are the common factors of the denominator. And once we find the LCD, we're going to multiply it to both sides of the equation. That's the strategy for solving rational equations, right? So we did. We find the LCD is 30. Here it is. And we're going to multiply 30 through the equation, right? And when we do that, guess what happens? We eliminate the fraction because 3 goes into 30 10 times, so we get 10 times, so now we're on this equation here, 10 times parentheses 2 minus, or t minus 2, minus 6 parentheses t plus 7, and why 6? Well, the 5 cancels into the 30 and we get 6, and then we have 10 goes into 33 times, so 3 times t minus 4 plus 60, which is 20 times 30. Okay, then we start doing the distributive property. We distribute the 10. We get 10t minus 20. We distribute the 6, minus 6t minus 42. Notice the negative still is carried with the 6, is equal to 3t minus 12 plus 60. Now we combine like terms, right? So we're combining like terms. Whatever we have on the left side, we combine. We see it's 4t minus 62. And on the right side, it is 3t plus 48. Now again, we're going to use the principle of equality. I bring the t's over. So I subtract 3t from both sides, I get t. I add 62 to both sides, I get 110. And then, of course, I check my answer. When I put 110 in, I get, on one side of the equation, 63 over 5. And on the other side of the equation, I get 63 over 5. So now we have a little bit more complication. This is problem 63 on page 111. Now, the idea here is we have, in the denominator, we have a complex polynomial in the denominators. So we have to find the LCD first. To find the LCD, we have to factor, and remember in the skills we had to factor polynomials of second degree. So we do the first one, x squared, so we're over here. X squared minus x minus 2 is equal to x minus 2 times x plus 1. Then we do the next polynomial, x squared minus 4 turns out to be x plus 2 times x minus 2. And then we do the last one, which is x squared minus 3x plus 2. And we factor that and we find it's x plus 2 times x plus 1. We want to note that we can't have solutions of the following. X cannot be 2, x cannot be negative 2, and x cannot be a negative 1. Well, now we have to find the LCD. The LCD is the least number of factors that I need for multiplying through the equation. And to do that, we see that we have an x plus 2. So we get an x plus 2. We get an x minus 2. And we get an x plus 1. So our LCD is the multiplication of those factors. So the next step is we're going to multiply through by the least common denominator. When we do that, we will not get a fraction. Why? Because when we multiply through by the LCD, one of those factors or two of the factors will cancel out. So in the case of 5 over x squared minus x minus 2, the two factors that'll cancel out are x minus 2 and x plus 1. So I'm just left with x plus 2. So I'm left with 5 times x plus 2. Now when I multiply the LCD by the next term, a negative 2 over x squared minus 4, I know that I'm left with just x plus 1. So I have a negative 2 times x plus 1, and that's over on the left-hand side of the equation. And finally, on the right-hand side of the equation, 4 divided by x squared plus 3x plus 2, I'm just left with x minus 2 times 4. Okay? Now we use the distributive property in the next step. So we have 5x plus 10 minus 2x minus 2. Notice the negative still carries. And then on the right hand side I have 4x minus 8. And then finally I combine like terms. So on the left hand side I have 3x plus 8 is equal to 4x minus 8. I use the principle of equality and I get x is equal to 16. So that is my answer. And I hope that you could follow through on this particular problem. So also in this particular chapter we're looking at solving for a particular variable when we have more than one variable in the equation. So this is problem number 85 on page 111. We have 6 is equal to 4x plus tx, and we're going to solve for x. So the first step in this particular case is here's the equation, and then we're going to factor out an x from the right side of the equation for those terms, and we get 4 plus t times x is equal to 6. And now we divide both sides of the equation by 4 plus t, so we can isolate x because we're solving for x, and there is our answer there. So our last problem is kind of a word problem. We're using rationals again in this problem. This is number 108 on page 112. Dexter's truck gets 32 miles per gallon on the highway and 24 miles per gallon in the city. The amount A is given by the following formula. A is equal to 1 over 24 times C plus 1 over 32 plus H, where C is the number of miles driven in the city and H is the number of miles of the highway driven. If Dexter drove 60 miles in the city and used 9 miles or 9 gallons of gas, how many highway miles did he drive? So we set up what we know. A is equal to 9 gallons, C is equal to 60 miles, and we're trying to find H. So now the next step is we use the equation and we start plugging things in. But before we do that, we're going to solve for H like we did in the previous problem. So what we do is the principle of equality. We move A over or actually we move the negative 24c over to a, and we have negative 32. Now I can multiply both sides by 32, and now I have an equation h is equal to 32 parentheses or bracket a minus 24c. Now I have h is equal to 32. Now I'm just going to put in the numbers. So for A it was 9 gallons, and for C it was 60 gallons, so I'm right here, right? So all I did was put in the numbers after I solved for h. Now I can solve for h by continually doing some numbers. I multiplied 1 over 24 times 60. I got 5 halves. So I have 32 bracket 9 minus 5 halves. And now I have 32 times 13 over 2 when I deal with the bracket inside. And now I get to see that 2 goes into 32 16 times, and I'm ended up with 16 times 13, and the answer is 208 miles. So in this problem, I solved for h first before I plugged in the numbers. I don't necessarily have to do that. I could use the original equation and put the numbers in and then solve for h that way. So there are multiple ways to solve this problem, whichever works best for you. Well, that concludes section 1.1. We also want you to look at section 1.2.